Hi everyone! Today we are going to look into using similar triangles to solve problems. Before we get started, I wanted to point out the properties of similarity. They work just like the properties of congruence. Remember, we have reflexive, symmetric, and transitive. And if you need to refresh your mind on those, there they are. Okay, so let's say we wanted to solve this problem. It says find BE and AD, justify each step. I see that I have these parallel lines here. So what that means is with a transversal, I get congruent angles because of corresponding angles. So based on those congruent angles, I could say that these triangles ABE and ACD are congruent. It's sometimes also helpful to redraw this as two separate triangles that are not overlapping. Remember, we would also know angle A is congruent to itself. So based on this, you might want to write your your similarity statement. Triangle ABE is similar to triangle ACD by angle-angle similarity. Tells us to justify each step, so we should do that. Now, based on the fact that triangles are similar, I know that the sides are proportional. So I'm first going to look to see if I have a pair that I know both of the measures. I know AB corresponds to AC. I know both of their measures, 3 and 5. That will help me find the similarity ratio. We've done problems like this before. This time we're just justifying each step. So what I'm going to do is I'm going to put triangle ABE in the numerator, triangle ACD in the denominator, and I'll need to be consistent on that. Next, look for the side that has X, that is BE. I know that BE corresponds to CD. So I can set this equal to x over 3.5. Now to justify this, I can say the sides of similar triangles are proportional. Once you have the equation set up, I don't need you to use the multiplication property, all of that when you're solving. That's fine. You don't need to justify those steps. It's okay with me if you just justify up to the point where you have your equation set up. Now, in order to solve this, we need to cross multiply and divide. We'll cross multiply 3 times 3.5 divided by 5, and you should get x equals 2.1. Now we're going to do almost the same thing for y. I'll stick with this ratio, 3 over 5, and set it equal to, now let's look what sides are corresponding that have y in it. I know AE corresponds to AD, so I'll put y over y plus 3. Again, the corresponding sides of similar triangles are proportional. I'm going to move that up to give us a little more space here. Alright. So when I cross multiply this, I have 5 times y and 3 times y plus 3. Remember, I need to multiply the 3 by the y and the 3. I'll have to distribute it. Don't forget. A lot of people forget to distribute that 3, and they end up with just 3y plus 3, but that gets them a wrong answer. Alright, subtract 3y on both sides, you get 2y equals 9. Divide both sides by 2, and you should get y equals 4.5. But we're not quite finished yet. Once we get x and y, it actually asks us to find BE and AD. BE is easy. BE is just equal to x, so BE equals 2.1. That's just substitution. However, for AD, it's not just equal to y. AD is equal to y plus 3. So AD is equal to 4.5 plus 3, so 7.5. Alright, I want you to pause the video and try the practice problem seen below. Here's the correct answer for A. Here's the correct answer for B. Alright, let's do another problem. This one is going to be more a real-world problem. It says, Hallie is estimating the height of a roller coaster. She's 5 foot 3 inches tall and her shadow is 3 feet long. If the length of the shadow of the roller coaster is 40 feet, how tall is the roller coaster? As a hint, in shadow problems, you can assume that the angle formed by the sun's rays with any two objects are congruent. So what that means is that this angle is congruent to this angle, and that the two objects form a right angle with the ground. So based on the fact that those angles formed by the sun and the right angles are congruent, we can say these triangles formed by the objects and the shadows have to be similar because they have two angles that are congruent. That's angle-angle similarity postulate. Now, before I get this started, I want all my measurements to be in the same units. These are already in feet. So I want to go ahead and change 5 foot 3 inches into just feet. So I already have 5, that's my whole part. Now 3 inches, I need to change that into feet. I can do that by multiplying by a sneaky 1. I know that there are 12 inches in every 1 foot. My inches will cancel out. Now I have 3 and 12 that can reduce. They're both divisible by 3. So I get 1 times 1 is 1, 1 times 4 is 4, so that's 1/4 of a foot. So altogether I have 5 feet plus 1/4 of a foot, that's 5 and 1/4 foot, or 5.25 feet. Alright, now let's look at the corresponding parts. Since this angle from the sun is congruent to the other angle from the sun, and this right angle is congruent to the other right angle, I know these two sides must be corresponding. So I know 5.25 corresponds to x. Now let's find another pair of corresponding sides. These sides by the base, the ground, the shadow, have to be corresponding. I need to be consistent. I put the 5.25 from Hallie's triangle in the numerator, so I have to put the 3 in the numerator on the other fraction. I put the roller coaster in the denominator, so I need to keep the roller coaster in the denominator. Now, once you have it set up, this is just a simple cross multiply and divide problem. So you do 40 times 5.25, and then divide that answer, 210, divide that by 3, you get 70. Now what this means is that the roller coaster is 70 feet. Alright, finally, I want you to reflect on this. Please draw a triangle that you know is similar to triangle ABC. Obviously, a lot of you will have a lot of different answers. I want you to explain how do you know it's similar in 1 to 2 complete sentences. That's all for today. Tomorrow we'll be back to talk about proportional parts within triangles. See you then.